Hello friends, welcome to Dr. Ossai Physiology Academy, DOPA for short. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. All right, so if you are new to this channel, you're especially welcome. And if you like the content we drop, kindly click the like button, the subscribe button, and also turn on notifications so that you don't get to miss any new content we drop. All right, so let's get right into it. Now, gastrointestinal motility part 2. In the part 1, we talked about mastication and deglutition, which is chewing and swallowing. Okay, so learning about all this process, physiological process, can teach you vital health lessons, life lessons, and even management lessons. Right? So now in this part 2 of GI motility, we're going to be dealing with gastric motility. Remember, we said in the previous lectures, earlier lectures, that whenever I talk about anything gastric, you're referring to what? The stomach. Right? So gastric motility. Now, from the part 1 of this lecture, what we did was to talk about swallowing, which is the movement of food from the mouth to the stomach. And it ends by the lower esophageal sphincter relaxing to allow the bolus of food to enter. So it's a continuous process. It continues from where that one has stopped. Where swallowing stops, gastric motility begins. So very easy, very quick. Gastric motility also is divided into 3 phases for easy understanding. Now, let's look at them. Number 1, we call it receptive relaxation. Receptive relaxation. And number 2, it's called mixing and grinding. And number 3 is called gastric emptying. That's the end. Gastric emptying. Emptying. All right. So, receptive relaxation is just talking about the fact that as the bolus of food comes from the lower part of the esophagus, now entering the stomach, what does the stomach do? It welcomes the bolus of food. Receptionist, receptive, use that to remember it. A receptionist welcomes people. So this receptive relaxation is a way of welcoming the food. And it does that by relaxing so that the food can easily enter and find space to be stored. Because everything about this gastric motility, from this receptive relaxation to gastric emptying, takes about 3 to 4 hours. 3 to 4 hours. Okay? So what exactly happens in this receptive relaxation is the fact that as food enter, we talked about the fact that 2 major things that help to stimulate the activities of the enteric nervous system, intrinsic innervation, and all of that, is the fact that they have stretch receptor. Food stretches the GIT and is detected by stretch receptors. Also, food as a chemical also stimulates the GIT. Through chemoreceptors, they detect that, the presence of food. So those 2 things, they also, when food enters the stomach, it detects it. The vagus nerve, we say that it supplies from the parasympathetic 75%, including the stomach. It innervates the stomach. So that vagus nerve is part of what helps in this receptive relaxation. It helps the smooth muscles of the stomach to relax so that as food is entering, it can accommodate more and more food without increasing the pressure. Because if it does not relax and food keeps entering, the pressure increases and you feel some pains. Okay? So it relaxes the muscle of the stomach so that food can enter quietly, peacefully, and effectively. So that's what happens here. So that reflex, it's called a vagal reflex. Vagal reflex. In the sense that the vagus nerve sends the information, the afferent information that food is entering. Okay? So the vagus nerves also cause the relaxation of the stomach. So vagus detecting the food entering, vagus acting now to relax it. That's why vagal reflex. Okay? So the next one is mixing and grinding. Very easy to understand also. Everything in physiology is easy. That's why we're here. Right? So what does it do? Food has entered. It has the smooth muscles there, they go into action because they've already recognized from the distension of the stomach, the chemical composition of the food, and so on. They already know that there's food there. So they start contracting to mix, turn the food. Have you ever seen this where people are building a house? There's this mixer and grinder. They put concrete and it turns to mix the cement and so on, grind it. So similar thing the stomach does. It's big, very deep, the most distended part of the GIT. Okay, so what it does, it begins to contract and mix the food with enzymes and also grind it. It's doing that, it's grinding it. Especially the lower part. There's this lower part of the stomach. Okay, the stomach is like this, esophagus. The stomach is like this. Okay, then from here, the intestine, esophagus, intestine, small intestine. So this is the stomach. So this part, the fundus, the antrum, greater curvature, this place lesser curvature. So this lower part has, the muscles are very thick. Okay, they help to do a lot of grinding. So what happens is that there is what separates the stomach from the small intestine is a sphincter. And we said that's called the pyloric sphincter. Okay? So what happens is that when the food has been grinded and reaches this place, if the food is not broken down enough, it's not smooth enough, it cannot pass through. So what happens is that once it comes here and it's not small enough, it's not well grounded, it goes back. This muscle pushes it back to the stomach for further grinding. That process is called retropulsion. Okay? Retropulsion. So it continues grinding and grinding, mixing, till it is smooth and small enough to pass. At that point, where the content is now smooth and small enough to pass through this pyloric sphincter, the content is no longer called bolus. It's now called what? Chyme. So we'll start referring to it as chyme, chyme, however you want to call it. But this is how it's spelled, chyme. All right? So it's now chyme. It's now semi-solid form. Okay? The chyme. So that is the second phase of the gastric motility. Now the next one is now gastric emptying. Now the food is now to pass from the stomach to the intestine. What are the things that are involved? What are the things that are involved? It simply involves the relaxation of the pyloric sphincter for the food to enter into the stomach. And there are important factors that determine the rate at which the content in the stomach will be empty. There are important factors. Sometimes within 2 hours, 3 hours, it has emptied. At other times, maybe 4, 5 hours before it empties. So what are those factors that determine the rate? They are easy to understand, especially the first and the second one that we'll mention. Okay? So one of them, factors that determine the rate at which the stomach empties its content. Number one is the volume. The volume of food. Okay? The more the food you eat, the longer it takes. That's very logical stuff to understand. Okay? So the volume. The more the volume, the longer it takes to empty it. And number two is the consistency. Consistency of the food. What do we mean by that? It's talking about how well grounded the food is. Is it smooth enough? Has it been broken down to tinier pieces? That's the consistency. So the smaller the food particles, the faster they empty. We talked about that in this retropulsion. Now, if it's not small enough, it will take it back. That is prolonging the gastric emptying. But if it's small enough, it will. So it means that if you chew your food well enough, that means your stomach gastric emptying will be faster. Okay? Than you just put rice in your mouth, you just swallow it, you don't chew it. It will take longer for that food to be emptied from the stomach. That's why when you eat eba, load eba in your stomach, you're swallowing big lumps. It stays in your stomach longer. A lot of people have experienced this. When you eat eba or akpu, you will not be hungry on time. Why? Because the food stays in your stomach longer because it was not chewed. Okay? Consistency affects that. So another one, number 3, is the chemical composition. Chemical composition of food. So what do we mean by the chemical composition? How does it affect the rate of gastric emptying? Let's think about it for a moment. Okay? So the chemical composition is telling you the class of food. You know, major classes of food. You have carbohydrates, CHO. You have protein, then fats. Okay? So it's chemical composition is telling you which type. So which one do you think will empty faster? It's this one, the carbohydrates. So the carbohydrates, they empty faster than protein. And proteins, they empty faster than fats. When you eat a food that is high in protein, it will not empty as fast as when you eat a food that is mainly just carbohydrates. When you eat a fatty food, it does not empty as fast. So you ask yourself, why? Okay? So what I think the answer is that carbohydrates, it can be 2 things. Okay? Number 1 is that, the body God has the creator made it like that. You cannot really tell. Just that the body has a way of detecting these things based on certain reasons. The body needs glucose, energy, a lot. And they come mainly from carbohydrates. It's easily released. Energy is easily released from carbohydrate food. So somehow the body wants, carbohydrate, prefer carbohydrates because it releases energy fast. Another thing too is that saliva, digestion of the food in the of carbohydrates starts right from the mouth. Unlike other classes of food, it starts from the mouth. You have salivary amylase. We call it salivary amylase that starts digesting carbohydrates. Okay? So because carbohydrates are more digested, they can empty faster. Then proteins too. Protein digestion starts from the stomach. A lot of it starts from the stomach. But fats, not much of it is digested until it gets to the intestine. So that could play a role in the preference. All right? Carbohydrate first, protein, fat. So the fourth one, the factors that determine the rate of gastric emptying is the pH of the food or gastric content. pH has to do with the measure of acidity or alkalinity. All right? So if the food is acidic, it doesn't empty as fast as when it is alkaline. Think about it. So the next thing you ask yourself is why? We'll get to learn that when we start talking about regulation. We'll link it to this pH. Why foods that are more alkaline, they empty faster than foods that are more acidic. So the next thing we're going to be dealing with is regulation of gastric emptying after this break. Welcome back. So this final aspect of gastric motility, we're going to be dealing with regulation of gastric emptying. Now, regulation, everything about how physiological processes are regulated or controlled, like usually through chemical means, chemical messengers, which in this case now, hormones, okay? Chemical messengers or hormones, or through electrical means, that's nerves, okay? So, and in this case, the nerves, they mainly come from within the GIT itself. That's the enteric nervous system. So, one of them, the regulation of gastric emptying, is the fact that when food now enters the duodenum from the stomach, the duodenum is the first part of the small intestine. The moment food enters there, because the stomach secretes a lot of acid. Okay? Secretes a lot of acid. So there are H receptors. That means receptors that detect acidity in the duodenum. So once they detect the high acidity, that's acid content entering the duodenum, what happens? They send a message, it activates. These are chemoreceptors. Okay, that this H receptor, chemoreceptors, they activate the myenteric plexus. All right, it activates the myenteric plexus to do what? To slow down gastric emptying. You see that? Why is it doing that? Now, we talked about this pH of food, and we'll relate it to this pH of food. That low pH reduces, one of the factors that reduces the rate of gastric emptying. Now, this is the explanation. Now, because when food enters the small intestines, what happens? Small intestine is connected to those accessory organs, especially the pancreas. So the pancreas secretes a lot of fluid and enzymes, pancreatic enzymes that help in the digestion of food. So, but the funny thing is that these pancreatic enzymes, they don't function well in an acid environment. So the acidity of the stomach will inhibit them from functioning. So they function best in an alkaline environment. So you see the reason. So if more acid is entering faster than the alkaline content that is being secreted from the pancreas, it will inactivate their enzymes and they will not function well. So once acid enters, it measures the acidity and it sends a message through interneurons to the mesenteric plexus in the stomach to inhibit gastric motility. That is gastric emptying. So slow down first, so that we can have enough time to neutralize the acid we are bringing. So when we have neutralized it, it now inhibits this reflex. It's a reflex. It's called the enterogastric reflex. Very important in regulating gastric emptying. Entero is talking about intestine, gastric. So the reflex is from the intestine, that's the duodenum, sending a message to the stomach to reduce its rate of contraction and motility, so that it will allow enough time to neutralize the acid content, so that the pancreatic enzymes can function well. So that is what happens here, enterogastric reflex. All right? So the next thing, the regulation. So this entire is the nervous mechanism of regulation. So the next one is a hormonal mechanism. So when food enters the duodenum, it causes release of certain hormones, hormonal mechanism. One of the chief hormones there is called cholecystokinin, CCK for short. Okay? So cholecystokinin is one of the major hormones that helps to reduce the rate of gastric emptying. This cholecystokinin, it responds a lot to food that has a lot of fatty content. Remember that we said that based on the chemical composition, that fats are the slowest to empty. Okay, the rate of emptying. So it's related to this also. When it has a lot of fatty content, it stimulates this hormone a lot and it's produced. This hormone now inhibits gastric emptying. The body does not like too much fat to come into the duodenum too rapidly. Okay? So this does functions to inhibit further emptying. Now another enzyme is called vasoactive intestinal peptide. Okay? VIP for short. So this one also inhibits gastric emptying. This vasoactive intestinal peptide, you can also call it polypeptide, but it's still the same VIP for short. Okay? So it has other functions. So it functions even as a neurotransmitter and all of that. And it has other functions in other parts of the body, even relaxation of the smooth muscles of arteries and all of that. But one of its functions in the GIT is that it relaxes the smooth muscle of the stomach, which helps to slow down gastric emptying. Okay? They're released from cells in the intestine. All right? So this is the hormonal. These two control mainly the hormonal. There are other hormones. You have another hormone, gastrin. Another one called motilin. When we are dealing with gastrointestinal hormone, we'll deal more detail with this. But just mention it. I'm just mentioning it here to relate it to gastric emptying. These ones are positive. Okay? They enable gastric emptying. Why these two? Negative to gastric emptying. Okay? Gastrin motility enable, stimulate gastric emptying. CCK, VIP, they inhibit gastric emptying. Hormonal mechanism, this is now the nervous mechanism that through the mesenteric plexus sends message from the intestine to the stomach to inhibit it because of this this what stimulates it. Chemoreceptors there. All right, so this is what you need to know basically. Basic knowledge about gastric motility. Okay, so I've written quite a few books on physiology, especially in one in GIT physiology. So you can see the link below this in the description box for the soft copy. You can download it in a Okada books just for a little token, okay, for further reading. Also, check out our websites. The link is also there so you can see some other things we do to enhance the learning of physiology, making it easy, exciting, and effective. So, see you in the next video.